get off on a start here. Oh, by the way, the title is more about pollination and native bees than it is about commercial beekeeping. So that's the direction we're going. You've got a lot of information, from what I understand from Linda, about the traditional beekeeping of the honeybees. So I'm going to move on to a review of pollination and address mostly native bees. So that's what we're going to do. So review of pollination, what native bees might you find in your garden? How is evolution played here? What's the contract, if you will, between the bees and the plant? And then we'll take a run through some really good pollinator plants, and I'll identify the kinds of insects that you're seeing. At the end of the presentation, there's 2 lists of bee-friendly flowers, one that I created and one that Elaine Evans in the entomology department created. So those will be there for your reference. But this is what I was saying before. What will you remember most about this presentation? So if you make comments at the end, say, well, were the videos the coolest thing, the photographs, there are a few illustrations, there are quite a number of word concepts such as what's the plant bee contact. So keep that in the back of your mind as we go through, because I'm a big believer in the videos, but you tell me what works best for you. So this is a review of pollination, and I want to come at it from the way that I assume you know a certain amount about this, but I just want to take it maybe one step deeper than you may have. Now, it may not be deeper than what you've taken, but it might be, and it's all around the theme of, to me, how fascinating this whole process is. So we'll look at the size of pollen grains, types of stigmas, those being the receptive female part of the flower, how the pollen tube grows, which is amazing. Not too much about flower attractants other than to mention them, and the way nectaries function. So we'll look at a picture of a nectary so you get a sense of, well, what are the bees actually doing and putting their tongue into when they're nectaring the flower, so-called. So this is an old familiar red illustration of the traditional pollination thing, and you can see that we have the with the stigmatic surface up here, which is where the pollen's received, and then the pollen germinates, the tube runs down, comes in here, pollinates or fertilizes the egg, and you have a seed. These are the male parts of the flower here, the anthers, and the magic happens when the pollen grains from here have to get to here, but often on another flower of a different plant, or sometimes on the same flower and sometimes on the same plant. And usually the nectaries are located in this area toward the receptacle in the bottom of the plant. So that's the general thing, but what I like to do is go, okay, well, that's fine, the pollen tube germinates, but what are some other things to think about? And one is, what's the size of these pollen grains? And I'll just say it now, but I'm going to make it, I'm going to try to present it in a way that makes it more comprehensible, that's the word. So we have a really tiny, probably the smallest pollen grain that I know of is the alpine forget-me-not, which is 3 microns. And the largest come from the cucurbit family, so cucumber has about 2 microns. So big difference in the size of pollen grains between different species, but also there's variation among the same species within the same genus and within a single flower and on the same plant to some extent. So how do you relate to this? And one way to relate to it is if you look at your fingerprint, and I'll show you a magnification of that, the ridge, you know, those are the things that give you such great capacity to feel things between, when you press them between your fingers. Why, you could be given a screw or a coin and be able to figure out what it is by those pressure ridges. So the two cucurbit grain, well, the width of these pressure ridges is a little less than half a millimeter. So if the cucurbit pollen grains are 200 microns, it means they're 0.2 millimeters, which means 2 and a little bit more would fit on the ridge, and 150 of the little alpine forget-me-nots would fit on the ridge, with the understanding that as things get below 0.1 millimeter, it becomes really difficult to see them with the unaided eye, with the understanding that if your eyes are mature like mine, that number keeps rising. So this is what the pressure ridges on a fingerprint look like. So this thing is this 0.45 millimeters. So the next time you look at your fingerprints, now you can know that that's the maximum size, roughly divided by, if you divide that by half, that's the maximum size of a pollen grain. And then they get to where 150 would fit edge to edge across the top, so pretty small. And these things have all these fascinating surface morphologies, which is bizarre. Like, I don't understand why how the evolutionary forces created all these things. They do often have this kind of surface texture, which allows them to stick. When they attach to something, they can stick to it. This is color-coded to help you separate these things. So the yellows are the prairie hollyhock, and the reds are the evening primrose, and the little red ones are the sunflowers. These green ones are castor bean, and these interesting things are oriental lilies. So in the big picture, that's what it looks like. If you take away the color and look at it, this is a prairie hawk, a really spiny thing that you can imagine. Some of these are really do great when they give you allergies. The evening primrose seems to look different in different photographs, so it's still this triangular type thing, but sometimes it seems to have a different texture. So they're pretty wild looking things, these pollen grains. Here's the castor bean, and then these bizarre surface structures on lily pollen grains. Now this is, so you go, okay, there's a pollen grain. What does that stigmatic surface look like? Where is that, where the pollen grains land? And I never knew it was so-called papillae, which are all these little towers here that help to capture pollen grains that can then germinate on this and in this surface. So this is the stigmatic surface here has matured a little bit, and these protrusions, papillae, lengthen as the stigmatic surface matures, so it enables it to capture these pollen grains a little better. So here's a plant that is often used in research. It's in the mustard family, and up here on the left you can see the pollen grain. Here's the pollen grain just starting to send out this a pollen tube, and here's the pollen tube in great manufacture. Here's the stigmatic surface of that flower. Here are a lot of pollen grains all coursing around this, and if you look over here, you can see that these are the pollen in a thing that's been stained in a particular way. You can see the pollen tubes that have grown down here, and they've actually moved across. It's not too easy to see, but this is where they've come over to the ovary and actually accomplished fertilization. So, when you look at them a little more closer, it's kind of a different thing than that diagram we looked at in the beginning. The other thing that's wild about these pollen grains is they're all different colors. Look at all these different colors. I mean, it goes from beautiful reds, oranges, yellows, blues, bluish gray, all these colors that are maybe make someone at the Home Depot paint store jealous, because these things have all these spectacular colors. There are also two different stigma types, and it has to do with how those pollen grains interact with the stigma. The wet stigmas, which I'll show you in a thing, have a different way of interacting with their pollen grains. They're not, because there's now a surface secretion, and the dry ones don't. So that's a little bit different. And the pollen grains, in some instances, have to move through the pistil or the tissue of the female part of the flower, which is solid. And so the pollen grain has to basically penetrate through tissue. And there's some that are hollow, like lilies, where it just crawls along the edge and does, but it has to know where to go, so it has particular orientations that tell it to go down toward the ovary. So you can see how the shiny aspect of this lily, which has the wet stigma type, and here's the dry stigma of an oriental poppy. And this whole germination of pollen is amazing. So it's on the surface, it germinates, it knows where to go, and grow, so it has a directional thing. And there's a lot of, in essence, chemical communication between the pollen tube and the cells of the stigma, because if it's a pollen grain that's incompatible with that stigma, the stigma basically shuts down the growth of the pollen tube, which is what happens in apples that have been pollinated with their own pollen. Whereas when it's another pollen, the cells in the stigma really interact and favorably help the growth of that pollen tube, which again results in fertilization. So this pollen tube grows, and it grows at the apex, and this is amazing. I mean, it grows right at the tip, and it continues to grow at the tip. It'd be sort of like building a skyscraper that was already enclosed, would never let any rain in, and yet would continue to grow in floors, and that's what these things do. And they don't grow in a steady rate. They accumulate the structural materials and then grow in pulsing. So they wait, accomplish these materials, then grow, and so the pollen tube grows a little bit, then it has to stop and wait until these other materials come. So it's really different and quite something. It's amazing also in the terms of how this little tiny pollen grain can grow so long. I mean, for instance, here's a corn pollen grain that's about 106 microns, so 0.1 millimeters, meaning if you right at whether you can see it with your naked eye, and this thing has to grow 8 inches, which is a really long way for something this small. So the ratios are often, if the size of the pollen grain is 1, the length that it would have to grow to fertilize the ovules can be from 1,000 to, from 100 to 1,000 to even more. So it's pretty wild what this thing is actually doing. At the same time, the plants, of the 270,000 named plants, plus or minus, some 60 to 70% of them are insect pollinated. And that means that these things have occurred, have evolved over the last, and you can decide where you want to start, 100 million years. Some people can say earlier, for some species it's later, but they've been together for a long time creating these interactions which affect both of them. And so one of the things that's evolved is these nectar guides, which are often out of our human visual spectral range, meaning they're often in the ultraviolet range, which is where bees can see in the ultraviolet ranges that we can't, and we see in the red where they can't. So that's really wild that they see differently, and yet the flower has stuff that guides them to where the nectaries are and where their sugar reward is. Often there are also olfactory clues, especially for moths and other flies, which provide an odor that these pollinators can pick up on and find the flower. And what out of this comes this sugar reward from the nectary. And these are cells that secrete a sugar solution, and they're often in different parts of the flower, but often they're a circular thing that runs at the base of that receptacle in the picture that we showed when we started. But also interesting here is the variation in timing. You'll find that plants, as they've adapted to certain insects, will try to avoid competition. So it may be that, to give you an example, the squash plant, as its flowers open and are most fertile in the early morning. And as it moves toward noon, they become less and less fertile, and the flowers actually close before the afternoon in most cases. And the one bee, a squash bee, is adapted to that and will live in the squash fields and is active very early when, as you would expect, the squash plant flowers are fertile. The next day, the fertility of the pollen grains is drastically reduced, sometimes down to 10% of what it was the day before, and the stigmatic surface is less receptive. So they have a real optimum window for this, and the nectar production is timed accordingly. So what does it look like in a flower when a bee comes up and sticks its proboscis tongue in here to lap up nectar? So this balloon flower, and you can see the flap here, and that's the stamen and the anther up here, and that flap covers this ring that exists down here of cells that are part of the nectary and secrete sugar. But what the plants evolved are these short hairs that limit the evaporation of this sugar solution, and the insects know right where to go, and they can stick their proboscis right through these hairs and catch the nectar. So to me, look at that. Isn't that wild that this thing protects its own nectar, and the bees know that, and they know where to go. So now the question is, well, okay, that's a review of pollination. We'll come back to some of that stuff, but what are the kind of native bees that you might see in your garden? And I won't overdo this if you've never been familiar with it, but there are a number of families in that have different bee types, and this Apidae is the one that has the honeybees and the bumblebees, and then some others you may not have heard of. This is a small carpenter bee and a longhorned bee, so-called. This is a leafcutter bee here. This is a mining bee. You'll see pictures of all these. This is the splendid green metallic bee, which is gorgeous. You'll see that. These are sweat bees, these two, and these are darker and, they're smaller things. This is a plasterer bee, which has an interesting tongue, and it secretes a material that forms a film in its nest site that is waterproof. So that protects the growing bee. Most of these bees are solitary, except for the bumblebees, which means that the female, after she's mated, digs a hole in the ground and then collects nectar and pollen, goes down into that hole, creates a little piece of bread with the pollen and nectar, and lays her egg on it and seals off the chamber. And then for that bee, her mothering is finished. And that bee will go through the rest of the year, and the next spring will dig its way out of that ground nest and start to cycle again. So it's not like a social bee where the bumblebees are social, and the only ones that live over the winter are the mated queens. And they have to start their hive again all over each spring. So the bumblebees that you see in the early spring are the queens. They're bigger than the workers usually because they need fat reserves to make their way through the long winter. And after the first generation of young bumblebees, they'll become workers, and she'll spend the rest of her time in the hive after that. And then at the end of the year, she'll produce males. Just as an introduction, I'll show you these different bees, and you can come back and review what they what they look like. But I wouldn't get too worried about that now. Just get a sense of all the different types. So of these native bees, 70% of these are ground nesting, and I'll show you what their nests look like. They need exposed ground or turf of a particular type that's not too tight. They have to make their way through it, and often they have, depending on the variety, some kind of secretion that they line their earthen nest hole with that keeps the integrity of that nest, keeps water out, often reduces fungal growth, and this is something that they've come about and secrete. It's just wild. Now the other 30% of these native bees are cavity nesting, meaning they're looking for tunnels, hollow stems. If you grow a perennial with a somewhat hollow stem like a raspberry, if they can find that dead stem, they'll move in there. There are other types that will take over the holes that beetles have bore, however you say that, have drilled, is the only verb I can come up with, in dead wood or stumps. So what I want to do is show you some of these videos. So this is a ground nesting bee, and the first scene is of it leaving its nest and coming back with the pollen that we talked about is what they make for the food for its egg. And the second one shows it digging the hole itself. So enjoy this. I always think that saying that they dig a hole is one thing, but then watching them dig it is really cool. So you see all that pollen that she had here, and here's that, she's just pulling that dirt and popping it out the top. There she goes. So, and sometimes she misses, like that. And so that's that one. Here's some video that I took of coletes. Now the coletes are these plasterer bees, and this is a park in Minnetonka. And if you start looking closely at the ground, you'll see the bee here. And if you look up here, you can see this one just flew in. That was tough to see, but I'll show you some better stuff. Here she is, and you can see she's dug the hole, and this is the diggings from the tunnel that she's made. And often they'll sit there in the cold, and you can see that if you startle them, how fast they are. So this is a little high-speed thing, so this is only quarter normal speed, and these are these bees leaving the nest with no pollen and coming back with their pollen collection. And so you can see how they have that. This happens fast. I mean, they're gone down that hole within the time they get within 5 inches of it. So it really only works, if you're going to see that, you've got to slow it down. And that's what you're seeing here. So I just thought that's pretty cool that you can see what these guys are up to when they're doing that. So one thing in this graph, that brings it all around, is this idea of here are the different bees, and they all have a different length of life cycle. So these bumblebees have multiple generations, and just know this is East Coast, so we're not expecting, bees around in March for the most part, although that 2012 season where the March was warmer than most Aprils, we did see some of that stuff. But the one thing to get is they have different lifestyle links, and so they're around for a certain amount of time and then they're gone. Other ones are around for a longer period of time. And what that means is if we're going to provide for them, we have to think of the flowers and that they would need for nectar and pollen through their whole cycle. Now, for fruit growers that grow these varieties, apples and plums in this part of the world, you can see, well, what of these bees here might be valuable pollinators for them? And it turns out some of these are great pollinators of these early arriving bees. So this gives you the sense of, okay, here are the bees again, here their life cycle, and then there'd be flowers, so we need to provide flowers that would fill in those spaces. The interesting thing is that these, as I mentioned before, the bees and the plants evolve together, and they develop relationships such that they need each other, and these things are intimate and synchronized, as we mentioned. So, but at the same time, there's a contract going on. There's interaction between them, and in a way, that's why we have the world we do, that has this extreme floral diversity and specialization. So it's all come about because there's an advantage to creating a system that's a little different than the other species, so that they're not directly competing, and that gives us a lot of the variability that we see. So here's the contract, the deal from the plant's point of view. The plant is going to produce a better genetic structure of its pollinations if it's cross-fertilized. So how does it get its pollen from one flower to the other? With the earlier earlier gymnosperms, they release all this pollen. It's carried by air. That's why your car is covered with pollen from the pine trees. If you go to any of the big parks that are dominated by those tree types, the plant also provides attractants to let the insects know where they are. It gives them a reward, a sugar solution, for coming to their flower, and it produces more pollen than it really needs to just keep itself alive, but that pollen is used by the insects as a protein source. And basically the plants need to manage the reward system, because if they have to manage the amount of nectar, because if they give the pollinators all this too much nectar, then they'll just fill up with nectar on that flower and go back to their nest. They need to give them just enough so they're encouraged to go to another flower. So this is a little trickier than you might think. And on the other hand, if they're competing with different species and other flowers that are also producing nectar, they can't stinge on the nectar, because then they'll become less attractive to the pollinators, right? So it's a balance, it's a dance that's going on, and the plants basically kind of manipulate the pollinators through this sugar reward system. They channel the behavior of these guys, and in the process, try to find a system that produces maximum numbers of seeds for themselves at a minimum exposure of energy in terms of production of nectar and pollen. The insect's view is, oh, I'll be happy to move your pollen around and meet your genetic structure needs if you provide the following, meaning I fly, I need energy, so you're going to provide me with sugar. I need protein for my young, so you provide excess pollen. You provide things that help me find you, nectar guides and odor, and other things that help me find where the nectar is in the first place. But there's other things, because think about it, if the insect went to this flower and then a totally different flower of a different species, what would happen? It would gum up the stigmatic surfaces with pollen from a plant that isn't related, and the pollen would never germinate there. So they have to have this habit of sticking with, it's called constancy, sticking with a certain flower type for that pollination run. So they will be taking pollen from one flower and taking it to another flower of the same species. And that's an important thing. The bees, on the other hand, are finicky. You give them sugar solutions less than 30%, or in this 10, 20, and they won't drink it. They'll go somewhere else. So it has to be of a certain concentration for the bees to like it. And from a health point of view, the bees really need a diversity of these types of things in the same way we need a diversity of different food types. And what we're seeing in our landscapes as humans and what we do on the landscape is we're reducing the floral diversity dramatically. Because if you think about it, what do we have in the agricultural areas of Minnesota? Corn and beans mostly. What do we do in our urban areas? We take farmland out, we put roads, houses, gas stations, schools, buildings, and they're dominated by turf. So we need to really think about this, and we can make a difference, in my opinion, by understanding the plants that are that will help these creatures because they're necessary for our own food systems and they're necessary for the biosphere in general. So we can't just take one plant and plant it and think, well, we've done our thing. The bees are looking for efficient things, and they're going to go to where they can see a number of plants and find a significant amount of nectar and pollen. If there's just one plant, it won't be attractive. So here is a leafcutter bee, and this leafcutter has its pollen collecting hairs on the base of its abdomen. So because it's visiting thistle, it's picking up these really cute light pink mauve color of the pollen here. And that's just a characteristic of these leafcutter bees. So why is nectar good? Well, the plant can produce it easily, it's readily digested, it's a good source of energy. There is variation in sugars, but most are in the range that the bees would find attractive. From the plant's perspective, its ability to produce nectar is going to be related to the way the environment's running. If they don't have enough water, they're not going to produce nectar. If it's hot and dry, it might evaporate, which is why they've developed ways to protect it. Depending on temperatures, cold temperatures can shut down the plant. They won't be producing it that way. Hot temperatures can stress the plant, so there's going to be an optimum temperature range, and there's going to be adaptation to different features of elevation and latitude. And the more you get into it, the more you're amazed at the difference and how the different ways that the plants deal with this nectar reward situation. The pollen from its side is very nutritious. It's well balanced. It has all these protein, starch, sugars, fats, antioxidants, and vitamins, and so on. But you can see that there's variation between the different species. And this one's dramatic because cypress is a gymnosperm, so it's wind pollinated, and its pollen protein, the protein concentration of its pollen is not that important. Whereas dodecathion is definitely going to need insects to pollen. It's come up with this really high protein content. So most protein contain essential amino acids and nitrogen that the bees will need for protein construction. But for our view of it, we need to develop a season-long pollinator strategy that it kind of repeats what I said about one plant being unattractive, and that the pollinators depend on volume, variety, and the bees. Not all bees visit all flowers. So there's some flowers that some bees can't get into, and other flowers that everybody can get into, and some bees just won't worry about it. So let's just take this kind of cool tour of some of these pollinator-friendly plants and see the kind of stuff that they've got. I mean, as a slide that's probably in the wrong place, these plants will have, will likely, if it comes up with this pollinator-friendly designation, it should have nutritious pollen. But at the same time, the bees are best served by a mixed diet, and often but not always wind-pollinated plants, the pollen of which is not as attractive as the totally insect-pollinated plants. So here's to make a case for dandelions that come out very early. And so what you're seeing are these mining bees, these andrenids. gathering nectar and pollen on dandelions. So I'm not saying you need to leave all the dandelions in your lawn, but if you can leave a certain amount, you will be providing for these early arriving bees. And there are other species that are in there. Notice the difference here. This one was striped, and this one is, well, barely striped, and you will continue to see things like that. So that was my shot for the vindication of dandelions to a certain respect, but some of the early blooming trees are critical for these bees and such. So here's a wild cherry tree, and you can see this is an andrenid with a solid black abdomen. Let's see, did we see? Yeah, see, I couldn't see up in this thing because there's a picture up there, but that's kind of a cool wing posture of these andrenids. Another early flowering shrub are blueberries, and you can see here this bumblebee, which is sticking its proboscis into this blueberry flower. Now, the blueberry flower corolla, this length here is about 11 millimeters, and the honeybee tongues are about 6. So these are tough flowers for honeybees, but many of the bumblebee species have longer tongues, and so that's why the bumblebees are really good pollinators for blueberries. But remember, it's only the queens that are available during blueberry flowering time. However, these andrenids with these brown furry thoraxes and these shiny green without stripe, sometimes abdomens, are great blueberry pollinators, and in some years they're accomplishing much of the pollination in blueberries. It varies a lot from year to year. One year it was 75%, and the next year it was like 20, given those weird springs we had, right, where, you know, we ended up getting 10 inches of snowfall in early May, which, if these guys were starting to come out, that was a bit of a shock. Crab apples are great. You'll see those andrenids as well. Here's another andrenid on raspberries. Raspberries are a very popular flower, so you'll see lots of things there. If you really want to see bees, plant some raspberries. Again, the bumblebees like them. Clover is another good thing to have. So having your lawn carry some clover is a good way to turn your lawn into a bee lawn, as long as you don't have toddlers running around the lawn and with no shoes on. So you need to think about, well, what's the purpose of the lawn, and will a certain strategy work? Some of these bumblebees are gorgeous. This is Bombus ternarius with these two orange belts on it. Just a really pretty looking bumblebee. Here's a swamp rose. Now we have roses that go all the way from this very open single flower to the hybrid teas that I don't think you can even access these things. So in those double flowers, the same things in peonies, right? You got peonies that are single flowers and peonies that are double pom-poms. Well, the double pom-poms have no flower parts of value to bees, but these open flower types do. And you can see, here's a big bumblebee, and to show you size differences, this is this little small carpenter bee that's visiting the same flower. Here are golden alexanders and one of the earliest flowering perennials, and here's another andrenid, and you can see that it's collected all its pollen here on the hairs on its upper leg, as opposed to the hairs on the abdomen of that leafcutter bee that we showed earlier. Again, another andrenid on wild mustard. They really like that. Here's an andrenid and another bee. I think that might be a leafcutter bee there. Wild mustard, they were going crazy for that. They love chives. This is a leafcutter bee on chives. Penstemon is a great thing. There's a leafcutter bee because you can see just those little hairs there in the abdomen that collect pollen. The baptisia is a great plant for bumblebees, but it's really hard for a lot of other bees to get access to this flower and push their way in. So that's a great bumblebee plant, but not such a great plant for other bees. I really like it. And there are white types of baptisia, and you saw the purple. And this is one of these large bumblebee queens. So here are some of the videos. This is a video on buzz pollination, and what buzz pollination is are the bees latching onto the flower and shaking with their wing muscles to release the pollen. So I won't show all of this, but I want you to see how much these are porous anthers where the pollen comes charging out the end of the anther through the tube at the end. And this happened so fast that this had to be filmed at 1,000 frames per second, which is like a factor of 33 slower than normal. And notice here's the stigma, the female part, rubbing on the bee's body, picking up pollen that it would get from this flower and the next. And you can see here the pollen that it's collecting that they'll put on a sled, which is, it'll take pollen and make that shiny ash by mixing some nectar with it so it sticks really well to its leg. And so it's just shaking it. So this is not an isolated thing. There are a number of plant species that have evolved this. You need to shake this flower at a certain frequency to get the pollen. Tomato is actually one of them as well. So I just wanted you to see these bees in action and know that so much of what they do is beyond our ability to perceive it because it's happening just way too fast. So if you slow it down, then you can see what it looks like when these guys are buzzing on these flowers. So let's see, I think I'll go a little bit further on this thing because there's a nice shot of someone here. Here is the tuning fork, and when it hits a certain frequency, you can see it'll start to release the pollen from those anthers, and it just pours out. So that's what these particular flowers have evolved to separate themselves from others and develop a particular relationship with a pollinator. So in the interest of time, I'll keep moving. Here's it's called Melisodes. It's a longhorn deer bee tribe. And you can see here the pollen collecting hairs, which is often a diagnostic feature on some of these different bees. And here it is on Anise hyssop, which is a plant I highly recommend. It produces nectar all the time, and it so many different bee species just really go for this. But you can see this looks a lot different than some of the other bees we've been looking at. Here's that Bombus ternarius also working this Anise hyssop, and you can see those orange stripes. Here's another Bombus bimaculatus because of these two little hairs here. So that's the way bumblebees are often distinguished. And here's this longhorned bee. Look at the length of those antennae in this particular bee. That would be a male. Borage is a good plant for bees. The honeybees like it. I think it's a pretty cool looking plant just on its own. Here's a honeybee working it. Here's a bumblebee working it. Wild bergamot monarda is an awesome bee plant, and here's a male leafcutter bee working in here. I'll show you why. You can say it's a male. These flowers mature starting in the center and then work their way to the edge, so the bees have to hang out there and work their way through this corolla to get to the nectar on this plant. It's quite a pretty plant just in its own right. Here's Liatris, another good plant, one of those long-haired bees. Here's the leafcutter, right, and another little skipper butterfly on Liatris. And here's a video I took of this leafcutter bee. Now, the leafcutter bees are called leafcutters because they co-cut leaves, and what they do is they wrap them, they line their nests with them. So this is a video at true speed. So you get a sense of how fast these bees actually are. So you see that's the female carrying leaves into this little hole. I had to put this tag here, this stake, so I could tell where the hole was because it looked like it flew into the ground and I couldn't follow it. And they still look like they're running into the ground, look how fast they come out of that hole and take off. Now, they were taking about 45 seconds to leave that hole to go over to cut this leaf and come back and put it in their, line their nest with it. So this is the same bee coming back and forth and continuing to build this particular nest. And so it's pretty fast. So I'll show you another one that slows that down. So this is a leaf cutter bee. Now this is about, you can see that you can actually see the wings working, because this is like 1,000 or 2,000 frames a second. So we slowed this down by a factor of 30 or 60. I think it's probably 60, but you need to slow it down even more to really watch the wing motion. I'll show you what the wing motion looks like with the dragonfly later. But here's the thing, this is a leaf cutter bee. Again, you can see it carrying that leaf underneath it, and it'll use oblong leaf pieces to line the sides of its nest, and it'll use circular ones to seal off the chambers. Now, here's the thing to remember is, if this is 2,000 frames a second, what you're seeing now occurred in approximately a second. So they have to negotiate and fly around these grass stems, and it looks like they're having a tough time. But remember, it only takes place in a second, so they're just moving very quickly, and this is the only way you can see what they're up to. And so they're creating nests under this rock ledge, and they've removed the dirt back in there, and this is one of the leaf cutter bee coming out, because you can see when they're building the nest, they'll be carrying leaves, and so that's why this one is doing that. Later, you'll see them carrying pollen, and I'll show you a picture of that as well. So those are leaf cutter bees, and in truth, that was right in my front doorstep. So you don't have to go far to see these cool guys. And here's a plant of this is the plant that leaf cutter was tapping in, the one with the brown mulch and the white plant stake. So it was flying over to this and cutting these type of holes. You see, here's the oblong one to line the sides, and here's the circular one to line the end. It's a little more dramatic when the leaves get a little tougher, like in this summer sweet. Here's Culver's root, another good plant for the pollinator garden. And here's a funny one, because this is a male leaf cutter bee, and you can notice it has this modified front leg. Well, when it mates with a female, it drapes this thing over her eyes, and no one's figured out exactly why. Maybe it calms her, maybe it keeps her from realizing that she's made a big mistake. You tell me, but that's the purpose of this highly modified front leg. Another one of the Melisodes with these pollen collecting things that go all the way down, which look like those old cowboy chaps that weren't just straight leather, but retained the lamb wool on the edge. Joe pieweed is a good one. This purple prairie clover is gorgeous, and it has a lot of this beautiful orange pollen that this dark green sweat bee carries. Cup plant, another good plant. Here's a bumblebee on that. Boneset, which is related to Joe pieweed. Here's another sweat bee. Some of these sweat bees are this gorgeous iridescent green, which is flatter here and kind of speckled on this rough surface of its thorax. This is a little masked bee, and you can see here's the male with this facial mask that it has. And this bee is only probably 1/4 inch long, something like that. So that's a really tiny bee. Milkweed, always a great bee plant. Here's a honeybee and a bumblebee working the milkweed, and a number of honeybees on the milkweed, and then a little other native bee coming in over there. So there's a lot of players on these flowers. The flowers are these great gathering places. And here's this splendid green metallic bee with this beautiful green thorax and this black and white abdomen. That's actually a female. So look at all the difference you're seeing in the way these pollen hairs catch this female longhorned bee on coneflower, and then there are later blooming plants like the asters, where again you have one of these beautiful metallic green bees. Some other bees, lots of them, like these asters. They're an important fall plant. And here's an interesting one. This is great blue lobelia, and its flower opens it up so that these really tiny masked bees, you can see the female has a different facial type than the males, and two or three of them can go in the flower at the same time. This is a different small carpenter bee, so you get a sense of the sizes. But when you also notice that this is what a big bumblebee queen looks like when she forces her way into the flower. So the flower can host all these little ones and the big ones as well. Blanket flower is highly visited in the late summer, early fall with these splendid green metallic bees of a different species. And you can see that one was a green type, and then this one becomes a different blue, but still just as beautiful. Those guys are spectacular. Again, another green one on sedum, another good late blooming flower. Goldenrod is spectacular. It captures all sorts of stuff, including this Bombus ternarius with the beautiful orange stripes. There's another female Hylaeus, that little bee where the male had the complete mask. A leafcutter bee on thistles, another Melisodes or longhorn bee on thistle. So what I wanted to do now was go, okay, those bees fly so fast, their wings move so fast. Their wings move at some 250 beats a second. So it's just a blur. So what I did was I photographed these dragonflies, and the dragonfly wings move a lot slower, so maybe 70 beats a second. So I took this so you could see how the wings work on these insects. And if you will, notice how the leading wingtip will fold and will twist and come back. So the front stroke is forward, and the back stroke, the wing turns and develops lift on both the forward and backward stroke of the wing. So here's a dragonfly coming in for a landing. I always think that it looks like some, B747 heavy coming in, landing gear down. But look at the way its wings, the top ones are working in opposition to the lower ones, and they continue to do this different things with that leading edge to give them a lot of control. So these guys are spectacular flyers. See how that wing forward edge tilts back? So this one's coming along, and then it decided, no, I'm not going to land after all. So watch the power strokes as it lifts up and decides to go, here it is, boom, off towards something. I guess it may have seen something to go after. So to me, that is just, if you will, poetry in motion. And so that's, maybe I'll show you that again. So yeah, I think that's the thing that I like to say is that it's just fascinating to me the way these bees are. This is a new thing for me. I've been only doing this, I don't know, 4 or 5 years, and I thought we got to get a way to see how the wings work. So that's why I wanted to bring this to you, as well as the other behaviors that are just beyond our ability to perceive them because they're so fast. I don't know for you, one beat is kind of 1 second, and these guys are doing 70 to 250 beats a second. So they're really out of our realm, but it doesn't mean that they're not just graceful and beautiful So I encourage you to learn more about this. Take a look at the plant list, see if you want to learn more. If you want to plant some and invite them to your garden, I think that you'll find it's just fascinating. And it's something we need to do because we're really having a dramatic effect on the landscape by creating all these monocultures, as I said, the grass in the urban areas and the monocrops in the other areas. So this gives you a sense of what this plant list is like, and it shows a lot of these prairie plants as in the months they usually flower, and the colors of the flower and the extent to which they flower. So this is a useful tool to capture plants all the way through the season. Elaine Evans, my collaborator in the entomology department, she's finishing her PhD. She created this list, which is in the back of this presentation, and she's done it a little differently, but there's a lot of good information there. So that's it for me. If you have questions, I'm glad to answer them. So please feel free.
Wonderful. Thank you, Karl. That was really excellent. We have gotten a few questions in that I can read to you, and if others have questions, please put those into the chat box. Or if you're feeling bold, you can just unmute and say your question out loud. But a couple that we've gotten, why in nature are the pollen grains different colors? Do different colors attract different pollinators?
Good question. I don't have a great answer for why they're different colors. Boy, that's a great question. Would you like to do a PhD and work on it? So yeah, I don't know. I more appreciated just the difference in colors and how attractive they are. But you ask an excellent question, and embarrassingly enough, I don't have a good answer. But I'll tell you what, I'll go see if there's a reason behind it. I've talked to some other researchers who are interested in that question as well. So thanks, that's a great question. Any more?
People are excited about the plant list and the charts that you just showed.
Okay.
Is that on a website, or maybe it's even on our local foods college website? Do you know?
Okay, well, I'll make it available. The Elaine Evans list can be gotten on the entomology website. So if you do a Google search for the Bee Lab or the Bee Squad, you'll be able to find that one. And I'll find a way to put this up on the Yard and Garden line through the university, if you're familiar with that. There's a Yard and Garden line blog. If you go into the extension, the garden part of the extension website, and if you look for Yard and Garden News, you'll find it, and I'll see that it gets up there.
Great. Yeah, if you send it to me, or I can find it. I just wrote it down, and I'll make sure it's up on.
Yeah, I'll send it to you as well.
Perfect.
Yeah,
there is a great question about cultivars, cultivated varieties, and if they are as nutritious for bees as regular native varieties, I guess.
Okay, so that's an excellent question. And there's not really a simple answer, because there are some cultivated varieties that are good sources of pollen and nectar for these bees, and they may not be native, and they may have been developed through our breeders. But I think the point that the questioner is getting to is sometimes we as humans and plant breeders will breed something which and have no part of what the bee's interest is part of our interest, meaning they are not selecting for nectar or pollen quality or anything. They're selecting for what they're interested in, such as the color and size of sweet peppers. And in the process, they're almost always interested in creating varieties that are self-pollinated because it makes it easier and removes the question of where you're going to get a pollinator for this thing. So often the best bet, are native plants. Although, like I say, there are exceptions. One really good way to do this is to go to some of the native plant providers, which are usually not the big garden center types, but little things like Outback Nursery in Afton and Prairie Nursery and a couple of other places. And when things are in flower, go around and see where the bees are, see where they're going, what flowers they're going to. It's fascinating. You go there and they're all over the penstemon, or they're all over whatever else is in flower, and that's a good way to do it. But so short and sweet, yes, mostly it's better to go with the natives, but for other reasons as well, because they have deep root systems and are adapted to this area, but not always. Sometimes some of the bad boy invasives are great pollinator plants, but a pain in the neck, the great one being Canadian thistle.
There's a question about how small are the holes in ground nests?
Okay, well, that's going to vary with the size of the bee. So that those leafcutter bees are maybe a ½ inch in length, and so they're going to be a little bit less in diameter. So the holes look like ant holes, only they're too big. So they might be a ¼ inch, 3/8 of an inch in diameter, but definitely different than an anthill. But that one video showed you a different soil type where the balls came up. A lot of them, the soil clung together, so probably had a significant amount of clay. Often these bees prefer sandier soils. It's easier to dig through sand or soil with a high component of sand. So often you'll see hills that look like ant hills, but if that hole is in the ¼ inch, 3/8 inch, maybe a little bigger, then it's going to be a native bee nesting hole.
All right. There's not really any order to these questions. I'm just reading them as they come in. So this next one is somebody grows a lot of squash, and they just heard about squash bees, and they want to know if those are native to Minnesota.
I believe yes. And here's a great example of an association that's become, I think, rather limited for the bee. So that squash bees mostly go to those cucurbit flowers, and it's fascinating. So grow some squash and go, and as you probably know, there are male and female flowers on the same vine. And if you go and look inside the male flowers toward the later parts of the afternoon, you may find a number of male bees because they like to go into that flower where it's protected, and it's and they're hidden from predators and stuff. And so you open it up, and there are a whole slew of male bees in that, 2 or 3 or whatever, in that male flower. So that's where they'll sleep overnight. And that those squash bees tend to dig their nests in the squash field itself. So if you have a garden and you start seeing that's happening, I would recommend that you mark put a flag where you see that bee hole entrance, and then not till to any depth around that. Just let that one go, and then keep an eye out for them coming out in the spring. So cool plant, cool bee.
Yeah, that's really interesting. Does keeping honeybees have any, do they compete or have any detrimental impact on native pollinators?
Another great question, and it depends on the circumstances, but if let's say there is a study that shows if you put a bumblebee nest fairly close to a honeybee hive, it will negatively impact the bumblebees, because the honeybees, you know, they communicate about location of food sources, and if it's a healthy hive, it could have 25,000, 50,000 bees, and most bumblebee colonies, if they get up to 400, it's pretty good. So the numbers really don't favor the bumblebees. But if the bumblebee nest is not that close, and there are other types of forage around, they will not be so negatively impacted. But if they're in close competition, yes.
All right, you may have gone into this a little bit, but there's a question about hybrid versus heirloom varieties of vegetables, and if there's any difference as far as which is better for pollinators.
Yeah, that's an interesting question. I don't know that the pollen quality has changed if you go from an heirloom to a more of a commercial variety. I tend to think of that in terms of tomatoes, and tomatoes have no nectaries, and the only things that visit them will be bumblebees when they're in an enclosed space, like in a greenhouse. At least that's my experience. I guess other people have found that the bumblebees will visit tomato plants, but I haven't had enough in one place at one time to attract them. So the tomato flower is not a very attractive flower. And like I said, if it's in a greenhouse, the greenhouse guys will have to put bumblebees in the house to pollinate the tomatoes. If the tomatoes are out in the wind, they'll be pollinated mostly by the wind and the shaking thereof. So I can't say that the pollen is better or worse. The main thing with heirlooms is they're heirlooms for a reason, because they have significant flaws that make them not attractive to commercial growers for the most part. The attraction is, have we lost, taste and stuff like that in these new cultivars that were bred for better shipping and color. So that's an individual thing. I still regret the fact that I tasted one of those awesome heirloom tomatoes and no one could tell me what it was. So I couldn't find it again. So I know that they have a benefit that way. I'm not sure they have a benefit for the bees. And especially if they're tomatoes, that tomato flower is pretty restrictive in terms of what bees will visit it.
Switching directions, is there a mosquito spray that can be used that is not harmful to bees?
Okay, good question. So here's what I understand about that. There are materials that the mosquito control district uses to inhibit the growth of the larval stages of the mosquitoes. When they use that material, it presents no problems for the bees. However, when they go to attack the adults, they need to use stuff that, at least what I've seen them using, is tough on the bees. They're broad spectrum insecticides, and they will harm the bees. And we're working with the mosquito control district at one of my blueberry growers' fields, because they come in with helicopters and spray the heck out of everything on the other side of the road of this lake. And we want to make sure that if they can control it as in the larval stages, that would be the way to go. But the main thing to do would be to look at the label of the pesticide and see if it's harmful for bees. So most of the new pesticide laws will have a new honeybee icon picture and some information in the advisory part of the label that talks about how to not harm bees, and that if this pesticide is one that could harm bees, then you need to know more about it. And if it's a neonicotinoid, it's It's a systemic, which can get in the pollen and nectar, and that's a big discussion now as to how much gets there. But I would tend to avoid that one. If you are spraying the mosquitoes when it's getting toward dark, many of the bees won't be out there, so you won't be spraying it on them. And if it's a contact, then it's likely that the bees will not be impacted. So that would be a way to go. Find something that's a contact that you can spray when the bees aren't there, and the residual is such that when the bees come back, they won't be harmed by whatever pesticide or whatever insecticides left there. So there is an option for that, because you can avoid, you can spray that's not in the bees' normal flight time.
Speaking of flight of the bees, how far does a bee typically fly? And honeybees in particular, they want to know what range do, oh no, sorry, I'm getting this wrong. They want to know what range do native bees have compared to honeybees?
Okay, excellent question. The flight distance of bees is directly related to their size. So the bigger they are, the farther they can fly. And so bumblebees can fly just as far as honeybees. Honeybees can go, you got to remember that honeybees are going to be opportunists with preferences. So if they can find a good nectar and pollen source nearby, they're going to go there. If they have to go farther away, then they'll have to go there. And actually, in one of these last summer or something, the summer was such that it reduced floral opportunities, and the bees had to fly a lot farther, at least for the bee guy I know up in the Bagley area, and he felt that really negatively impacted his hives, and he lost hives where he hadn't in previous years. So they can go distances. They can probably go at least, well, I've seen 3 miles, 5 miles. The bumblebees can do the same, but as you get smaller, they go less far. So the little bees that I showed you, those little Hylaeus bees that are 1/4 inch long, they probably won't fly more than 100 meters. They'll try to stay very close to they'll try to build nests very close to where they get pollen and nectar. And it can be, if it's possible, and on my property, I have all sorts of opportunities for these bees, and they nest right on the property, and they have flowers right there. So depending if I can have flowers throughout the year, they won't have to go but 20 yards to find forage. But again, to repeat, the smaller they are, to the smallest bee, which would only go 10, 15, 20 yards, maybe a little more, to the biggest bees like the honeybees and bumblebees, which can go in miles, maybe 4, 5, but they would prefer not to. Good question.
All right, now we got one on mason bees. How common are mason bees in Minnesota?
Okay, let's see. I think mason bees are in the genus Osmia, and Osmia has quite a few genera, and I'm not sure how many of them are native to Minnesota. They have used Osmia as a pollinator in a number of different systems. Let's see, I'm at the edge here, but I think the alfalfa leafcutter bee might be in that genus. And there are a couple of bees like this that they would use in orchards. So I don't see them that much. Some of the reports I've seen, they did a whole report of bees working in apple orchards in Michigan, and they said they'd seen one mason bee. I typically, in my yard, I see 1, 2, which seems sort of strange. but I only see one a year. So I don't see too many, and mostly I see people buying them and seeing if they can become established by laying out nests and making sure they have water resources. And remember that those are very early arriving bees, and that's why I think it's tough for them in Minnesota, because, you know, they come out early and, you know, they may miss the willows, and there may be a time when it's tough for them to find forage. So I don't see them that much.
Okay, well, here's a question about something that we might see a lot of, at least I do. Somebody had the unfortunate experience of being stung multiple times when trying to pick wild raspberries, and they're wondering if you think it was hornets.
Well, here's the thing about getting stung. Most of these native bees are solitary, in which case they, and that's opposed to bees that are social. Honeybees are social, and therefore they have developed these different classes of bees, if you will. So there's a queen, there are male drones, and they're worker bees, and they're morphologically distinct. But those worker bees also take on different duties, and a number of them will guard the hive. The same thing happens in other social insects, such as yellow jackets, which are the only thing I've been stung by. I've not been stung by wasps, as commonly called, but the yellow jackets I have been stung on. Here's why: because the only surviving member of the yellow jacket line is an inseminated queen, and she'll find a place to hide in the, or to go to survive the winter, and then she'll start building the hive again in the spring, just like bumblebees. And these yellow jackets become aggressive, so you usually don't get stung by them in the beginning of the year because there aren't that many around. But as the hive gets built, now they have specializations, they have guard bees at the edge of their nests, and the problem is if you walk past a ground nest and those guys come out to defend their nest, you'll get stung. But usually you won't get stung until later in the year, like in August, when they build up their numbers. I mean, they're the most aggressive one I know of. And most of the other bees will only defend their nest. So these other bees, like the sweat bees and stuff, will sting you if they happen to be sucking sweat off of you and you slap them. But mostly that's not much of a sting because their stingers aren't that long, and sometimes they're not even tough enough to pierce human skin. So, but when you say you got stung around raspberries, my first question will be, do you know what kind of bee it was? That may not be easy if it's coming after you and you have to go, what? The last thing you may be thinking of is, what is this particular bee? In the same way that if you're being chased by a tiger, is it one with, you know, horizontal or vertical stripes? Sorry about that. But if I have heard of people getting stung by bumblebees, when they sort of stumbled into a nest area and there were a number of bees around to defend that. But that's not usually in raspberry season because they usually haven't developed too many workers, and so there's no workers to defend a hive. And now raspberries is on the edge, so they could start earlier. Maybe there might be some workers around that would sting you. Mostly I'm surprised to hear that you got stung around raspberries unless they landed on you and you automatically tried to hit them, because you likely would not get stung by these solitary bees, and the nests of the other types probably haven't built up very much by the time raspberries are flowering. So I can't answer that too well, other than to, if you know what you were stung by, send me an email and tell me what it was, and we'll figure it out. But like I said, I'm repeating myself. I'm surprised you got stung in that circumstance. Most people get stung by yellow jackets in the late summer, August.
We have a question about honeybee hives and how far apart do they really need to be?
Well, yeah, okay. Now I have to tell you, I'm not a honeybee expert, so I can kind of address it, but I have to let you know that this is not my area of expertise, and so I'm not sure I can give you a good answer. There are different strategies as to how to place honeybee hives in various crops so that they will move throughout the crop and pollinate as much of the area as possible. So there are strategies of placements that way. And sometimes the beekeepers place their hives together because it's easier to do that than it is to have hives all over the place. But, you know, I really can't say. I'm not sure what you're asking, whether they compete with each other. If the hives are closer, it sort of depends on what forage is available, because if they're close together and they're in the middle of an almond orchard and there's just huge amounts of flowers, then I don't know that there would be an issue. But I'm not sure what you're asking, and I'm not sure I can answer. Sorry. Call or write an email to someone in the bee squad in Marla Spivak's lab and ask someone that question. I think you'll get a much better answer.
Yeah, that's good advice. And there's a question about man-made, let's see if I can find it. Are man-made nests effective?
Great question. So it depends what you're talking about. I think you're talking about the stem nesting bees and the fact that we can take a block of wood, cut it in half, and run a router through it, and then put it back together so that there's a hole, and then hang that kind of thing out. So I've done that, and I've had some success in getting these stem nesting bees to adopt that kind of thing. You can take different wooden straw type things of different diameters and put them together in a bundle and lay that out, and sometimes if the back is solid and the only one end is open, then you can get other stem nesting bees to take up in those sorts of man-made things. I find that some of the stem nesters, especially the mason bees, back to them, are kind of finicky. I mean, they want access to a particular soil type and access to particular water so that they can use that mud as part of their nest building. And if it's not there, they'll, even if you buy them and let them loose on your property with those kind of nests, if they don't find the other things they want, they'll just go somewhere else. So they're picky. They need to find the exact right spot. And I think it's kind of hit or miss. You're lucky if you get a few, and you probably shouldn't expect to get massive numbers unless you make a completely different effort, like the folks who are using those bee types in orchards as their main pollinators. So man-made nests can work. Usually they're tough. The man-made nests for bumblebees are pretty hit and miss, and more often than not, they will not be adopted. But you can get sometimes low adoption rates with these man-made nests with holes for stem tunnel nesting bees. I have seen small nests like that have maybe 20, 25 holes, and they're all filled. They've all been used. But that was in Montana, and I don't see that kind of activity here in Minnesota.
We've got a couple questions on urban beekeeping. First of all, is it successful? And second of all, what recommendations do you have for communities who want to promote urban beekeeping?
Okay, so that's now a big thing, and it's happening across the country. As you probably know, there are many high buildings in Minneapolis that now support beehives on their roofs. And some members of the Bee Squad are taking care of hives that are on top of the Minneapolis Art Institute. And that's only one of a number of other buildings. There's also a way, one of the things that the pollinator crisis, if you will, has generated is a real interest in beekeeping. And so a lot of people are, buying one hive, two hives, and putting it in their backyards. And it works. The bees in those things do seem to find flower resources. I mean, they're resourceful in that way. They'll go find them. So you can have success with that. You need to be careful because, I mean, one of the experiences that some folks in Minneapolis had, they each had 2 or 3 hives. They were all within a mile or so of each other, and somebody sprayed fipronil, which is a really tough insecticide usually used for termites on house foundations, but somehow it ended up on flowers, and the bees from all 3 of those different beekeepers found those flowers, and all of their hives were killed within an hour of each other. So, we try to avoid that kind of stuff. That was probably not a legal application. It certainly would have been legal now if it killed all those bees, but no one came forth and said, well, I was the one that did it. So, I would look into that more. I would talk to, local beekeepers, and, because it's building, and you can find other folks that are really interested in that and get their experiences and learn from them how to do it. I mean, managing beekeeping, honeybee hives is very rewarding, but it requires understanding their life systems and what diseases they can get and how to manage them. And the thing that always happens is whenever you're a beekeeper, you're relying on somebody else to grow the flowers. You can never grow enough flowers for yourself to support even one honeybee hive. It's tough because you need acres. But think about where you are and are there flower resources and who else has bees near you, and then explore it. So I think it's a fun thing to do. It really ties you in with what's happening in the natural world. So I certainly encourage it, but I wouldn't be the one to tell you all the information. Again, that would be something to take to the Bee Squad. But I would encourage you to do it. I think you'll have a great time. I gave a talk, one last thing. I gave a talk the other day, and I researched that, and this is happening in all of the cities throughout the country. I have pictures of bees in Alabama, San Francisco, Seattle, Fargo, places in Tennessee, New York City, Boston. So it's a big thing. It's happening, and you can find people that are doing it. So sorry about that addendum.
No, that was great. I think it's really cool that we have a Bee Squad. That's excellent. There was a question. I saw another one just came in, but there's one not about pollinators, but someone wants information about deep winter greenhouses and season extension. So number one, I should put in a quick plug. Next week, same time, same place, we will have Karl Ford, not to be confused with Karl Ford, no relationship, but she will be presenting for an hour about deep winter greenhouses. So that is an opportunity to get more info about that. But do you still do some work, Karl, in the area of season extension? And can people email you with questions related to that?
Well, I'm still involved in that to a certain extent. There's a season extension high tunnel workshop that's coming up in a couple of weeks in Brainerd, I believe. So look for that. It has a beginner half day and then another day and a half of topics for more advanced growers. Anybody that grows vegetables commercially, I think, will find themselves at a big disadvantage if they're not using high tunnels. The high tunnels provide protection, they provide early heat. The vegetables come out cosmetically better, and they come out earlier. So that's my opinion about those things. And the work continues on that to make them better. People are learning how to heat them with solar things. They're learning how to store other heat energy, because a high tunnel is really a heat, a heat storage receiver in its own, because it's going to capture light rays and build heat inside, and then not let the heat escape in the same way it came in. So yeah, those are, and I don't know what they mean by deep winter. They're three-quarter year tunnels where mostly the plastic is protecting fruits from rain, and if it rains on the fruit just when they're close to being harvested, it'll increase the water content, which decreases the shelf life and makes a mess of things, creates other disease issues. So people are finding that it really makes a big difference to grow a lot of things in these tunnels, whether they're three-quarter year or year-round. I think that's what you mean by the deep winter ones or the year-round ones, and there's ways to approach that with double lining on your tunnels, and even other plant protection material within the house itself, which does even a better job of retaining the day's heat. So yeah, I'm doing some of that stuff, but I'm more of an economic approach. I have more of an economic approach to that issue than I do an operations approach. One educator to talk to about that would be Terry Ninick. Terry's going to retire in a couple of years, but he'll be around till April, so take advantage of him and ask him. I mean, he's been growing those things. He's got like 8 or 9 himself, and has been doing it for ever since they've been coming in tunnels in Minnesota, so probably close to 20 years.
Well, thank you for the detour into season extension. And just another plug for next week for folks who would like more info on that. There is one more question about bees, and somebody wants to know if there are any bees that migrate.
Let's see. I've never been asked that question, so I need to think about that for a second. But I'm thinking that, not to my knowledge, that most bees do not fly those distances like dragonflies and butterflies, that they, they run a central, circle around where their nest sites are and forage there. They don't live long enough to take long journeys of that type. Most of these guys they wear their wings out, and their adult lives are in the sometimes 3 to 6 week range. And so that really doesn't leave much time for long migrations like that. So I don't know of any bees that do that. And you can tell the older bees, the bees have been around, because their wings start to get frayed. I mean, they're called Hymenoptera. Hymen means membrane, and optera means wing, and so they have these wings that that are tough, but they just wear them out. And you can see how 250 beats a second wears stuff out quickly. So no, I don't know of any migrating bees. Good question.
All right, and we've got another good one. The last question, we'll wrap up after this. Somebody wants to know if the traps that they put out for wasps will hurt bees.
Well, here's the thing. I'm not sure what traps you're putting out, but if they're directed toward wasps, then they may, the part of the trap strategy might be the fact that wasps are carnivores. And so if that's the way the trap is, bees are vegetarians.
It's, sorry to interrupt, they just clarified sugar water traps.
Oh, well, mostly I'm thinking that sugar water traps, why, you know, they'll attract a lot of those yellow jacket wasps in the late summer, fall. I don't think you'll find too many bees going to those traps if they're placed out then, which is maybe when you want them. I would ask why you're setting out wasp traps, because for the most part, if you don't bother them, they're not going to bother you, with the exception being of those yellow jacket wasps that have ground nests that build and you don't know that they're there, and then you're going to want to try to take care of them in one way, one fashion or another. But so explain to, if they can, please explain some more to me. Well, what time of year you're putting out these sugar water traps and why you're doing it.
So they're ground hornets.
Oh, okay. Most of the hornets I know, like the, what is it, the bald-faced hornet, have tree nests. But yeah, if they're ground nesting wasps, I don't know of any ground nesting hornets, but there might be. And yeah, you're probably not gonna, because if you walk by and disturb that nest, they're going to come out and protect it, and it's not going to be a pleasant exchange. So, you know, they'll come to sugar. Yeah, they can get drowned in that. That may be one way to handle it. I'm not sure how the trap is set up, but I understand why they would be attracted to sugar. I assume this is going to be later in the year because, as I said before, the numbers shouldn't be there in the early spring, early summer. And if that's the best way to do it, fine. If there was a way to avoid that area and getting stung, I would do that and leave them alone. If that's not true, be really careful about how you're going to try to handle these things, because, you know, they're fast and they're aggressive, and if they know that you're trying to kill them and they escape your initial efforts, they're going to come after you, and for some people that's almost dangerous. So if it's problematic, you could hire, you know, one of the folks that does that kind of extermination. But if you can leave them alone and stay away from them, great. If you can't, then yeah, manage it some other way. You'll have to tell me. I don't have any direct experience about whether those traps work, how well those traps work, and whether you get rid of the complete hive. I would think that they may get a number of individuals, but I don't know that they would get the whole hive, and so you'd be left with, you know, hornets or whatever being drawn to the trap, but you still may have the nest with a certain number of folks that still can be problematic for you.
Yeah, it sounds like it's somebody who wants to be able to harvest like raspberries, and that's where they are attracted to, and they aren't able to get to that area. And they said that they've used soda pop with a funnel to catch them.
Oh, okay. Yeah, I mean, because normally that, I am surprised because and I'd like to learn more, because normally those hives have been built up enough to create too many issues by the time you're harvesting raspberries. But your experience, you know, can certainly be different, and that can be an issue. So, yeah, if they're getting in the way of that, you know, I probably look for, you know, I'd wear pretty heavy clothes and try to wear, if you can have somebody has a bee suit, I'd wear that and maybe find some sort of a fog that you could spray into their nest if it's a ground nest situation. I wouldn't get creative and pour gasoline and try to light matches and stuff like that. You know, my first thought would be to consult with an exterminator. Or if you can, find a way to the raspberries around those guys, assuming that you haven't already tried that.
All right, well, thank you everybody for that excellent set of questions. And thank you so much, Karl, for a really engaging presentation. There were a lot of comments that came through, at least to me, thanking you for the video and the photographs, and they really were great.
Thanks, my great pleasure. So.